So we're halfway done now. 05C-60. So we have a circular arc and two right triangles it mentions. So that's a right triangle and that's a right triangle. They also share the same shape. So they're similar. They're similar triangles. Now that's important because we can set up a ratio between them. Um, we know these two corresponding sides, so 0.467 and 5.69. We know those two are the same relative side. They're the same corresponding sides. Um, it's been a few years since I've been in geometry, so I don't know the exact term. But we can use these two to find a ratio between the two triangles. So let's do that right now then. So if we call this area right here x, which is the length of this strip right here of the small triangle, we could say that 5.69, that big side, right? If we say that big side over this big side, which would be x plus, it gives us this little stretch right here, 1.44. Okay, 1.44. If we set that, okay, yeah, let me fix that a little bit. Okay, over 1.44, good enough. If we set that equal to this side, 4.67 over just x, because there's no additional area there. So what I basically did was this triangle right here, this side over this side, is equal to, let me change the area, let me change the color to red, and I set that equal to this side over that side. And again, we did that because we know that they're similar, right? That's a legal move. I should have probably used the different colors whenever I was writing it, but it's fine. So now, if we use our numeric solver, so 5.69 over x plus 1.44. I think I forgot a decimal. It's kind of tough trying to type like this. Set that equal to 4.67 over x. And let's see what x is. So x right there is supposedly 6.59. So we know that stretch right there. Now we know if with this right triangle, at least with the blue one, we know the opposite side, we know the adjacent side to the angle. We can just use inverse tangent. So let's do that right now. Inverse tangent of 4.67 over the adjacent side, which is stored under x. And we're in degrees, so let's switch to radians so we don't have to convert. Radians. And 0.616. And that is our correct answer. Not too bad. You could have used the fact that it's a circular arc. You could have used that to your advantage. I didn't. I mean, I guess in a way I did, but I just mostly treated it as two similar triangles, which you knew because they both share the same circular arc, that angle. So 0.616.